So here's a second example with a slightly more complex shape. A uniform annular disk, it's essentially just a fancy way of saying a donut, or a torus, of outer radius 4 meters and inner radius 2 meters, is spinning uniformly through its center by two collinear torques of magnitude 77 and 21 newton meters. The moment of inertia for an angular disk is I equals a half m by r1 squared plus r2 squared. It spins at a constant angular acceleration of 0.125 per second squared. Firstly, find the mass of the annular disk, the rotational kinetic energy of the disk, and find the change in velocity after the second and third revolutions of the disk, and write a formula that represents the speed of the disk after n revolutions. So you can go ahead and try this problem, and when you're ready, come back for the solution. So we know that the sum of torques is equal to the moment of inertia by angular acceleration. So the 77 plus the 21 newton meter torques equals 0.125 I, which gives the moment of inertia of 78.4 kilogram meters squared. Next up, we're given the moment of inertia for an annular disk, which this is an annular disk here, is m over 2, or half m, times the sum of the squares of the inner and outer radii. So it doesn't matter which one you pick, because addition is commutative. So you get 784 is m over 2 times 2 squared plus 4 squared, and that gets you m equals 78.4 kilograms. Next, you have to find the rotational kinetic energy, so that's a half I alpha squared, which is 6.125 joules. Now for the third one is slightly trickier. It doesn't say it starts from rest, so it's very bad to assume that it does. So let's say it starts, or we start keeping track at a speed of omega naught. After one rotation, its speed will increase to omega naught plus 0.125, then omega naught plus 2 plus 0.25, and so on. So the change in angular speed or angular acceleration is 0.125, as we've discussed. So therefore, the velocity after n revolutions is omega naught plus 0.125 n times or, where or is the radius. Since v equals omega or, we have to stick it in, and of course we weren't given a particular radius, so we just have to take it generally.